Our next exponent video is going to be on the power property. Yesterday we talked about the product and quotient property, and this is the last one we're going to add in, the power property. And all the power property does is it looks at our rules of how exponents work and applies them along with the product property to come up with a rule here. And we have an example, x to the fourth to the third power. Well, in that case, you have x to the fourth to the third power, meaning x to the fourth times x to the fourth times x to the fourth. That's what the third power means. So based on what we said yesterday, when you have a bunch of multiplications, you add the exponents. So therefore, x to the fourth times x to the fourth is x to the eighth, times another x to the fourth is x to the 12th. So the power property recognizes there's actually a shortcut for this, because adding over and over and over again is the definition of multiplication. So therefore, when we have x to the fourth to the third power, the fastest way to get to our solution is to multiply power times power. So our rule is, when you are raising one power to another power, the exponents are multiplied. Let's look at a couple of examples of this. In our first example, we have 3x to the fourth y raised to the third power. In order to do that, we have to take everything in that parenthesis to the third power. We take 3 to the third power, x to the fourth to the third power becomes x to the 12th because we multiply the exponents. And then remember, if you have this lone y, there is a 1 assumed as an exponent on the y. So we do 1 times 3 is 3. So we get 3 to the third, x to the 12th, y to the third. However, we wouldn't leave our answer like that, because 3 to the third, those are just numbers. With numbers, we go ahead and do our traditional exponent rules. 3 to the third power is 3 times 3 times 3, which is 27, x to the 12th, y to the third. A lot of people get in trouble when we do this because they want to apply our exponent rules to regular numbers. 3 to the third is not 3 times 3. It is still 3 times 3 times 3. The old exponent rules still apply for numbers. We only have these new rules that apply to the exponents. To finish up, we're going to look at a second example that's a little bit more complex, and it's going to mix all the things we did yesterday with our new power property from today. And there will be one or two a little more complex from here that we will look at in class tomorrow as a group. So when we have 4x to the negative third times 2x to the negative fourth, y to the second to the negative fourth power, we first have to deal with this parenthesis. Just like order of operations, we've got to take care of that first. So I went ahead, and if you look here on the left, I copied 4x to the negative third, and I applied that negative fourth power to everything in the parenthesis. 2 to the negative fourth, x to the 16th, because negative 4 times negative 4, and y to the negative 8th. And then I copied the bottom, 3x squared, y to the negative 5th. From there, I went ahead and moved all the values that had a negative exponent on it. This x to the negative third moved to the bottom. This 2 to the negative 4 moved to the bottom. Y to the negative 8 moved to the bottom where they became positive exponents. Y to the negative 5th moved to the top where it became a positive exponent. Now we go ahead and simplify. The top is already simplified, 4x to the 16th, y to the 5th. On bottom, we have 2 to the 4th power times 3. 2 to the 4th power is 16, so we do 16 times 3 to get 48. Then you have the x's. X to the second times x to the third is x to the 5th, and the y to the 8th stays on bottom. To finish, we now simplify from top to bottom. 4 over 48 is a traditional fraction that reduces to 1/12. So we have 1 over 12. Our x's, there's 16 on top, 5 on bottom, so there's 11 more x's on top, so we have x to the 11th on top. And finally the y's, you have 5 on top, 8 on bottom. There are 3 more y's on bottom, so we stay with y to the third on the bottom of our fraction. So our final answer is x to the 11th over 12y to the third. These start to get complex in the way that there's a lot going on in one problem. However, if you will take your time and think of each step individually, the rules in and of themselves are fairly simple. Good luck, and make sure you're asking questions if you have trouble.